Hello everyone, this is Dr. Govind Rai Garg. In this video, we will start pharmacodynamics. So in earlier videos, we completed pharmacokinetics. We know pharmacokinetic is effect of body on the drug. So that is called as ADME study. Whereas pharmacodynamic is effect of drug on the body. So we'll discuss effect of drugs on the body here. So what is the outline of the chapter? We'll discuss what is pharmacodynamics, what are the general mechanism by which the drugs can work, and here in this video we will mainly concentrate on enzyme inhibitors. Okay, so we discussed pharmacodynamics. It is effect of drug on the body. So we will discuss two things in pharmacodynamics. One, the actions of a drug, what does a drug do, and second, how those actions are produced. That means mechanism of action. Yeah? So actions we will distribute in various chapters. We'll see the effect of drugs on autonomic nervous system, cardiovascular system, CNS. We'll divide it into various chapters. Throughout pharmacology, we are going to study that. So here we will discuss the general mechanism by which a drug can work. Generally, how a drug works. Yeah? So how a drug works generally, the drug may work by physical mechanism. Like simply physical presence of a drug produce the action. Yeah? You can see charcoal. There is some drug poisoning. The drug is still present in the stomach. We want that it should not be absorbed. Otherwise, poisoning will increase. So we will give charcoal by GI route. So when charcoal enters the stomach, it will bind the drug. Physically, it will bind the drug. And when it binds the drug physically, drug absorption stops. Yeah? That is physical mechanism. Then there may be chemical mechanism. The most simple example of chemical mechanism is antacids. You are developing acidity because acid is more in the stomach. So you give antacids. So antacid are basic substances. They will react with the acid, neutralize that. Simple chemical mechanism. Or we can say heparin and protamine. Protamine is antidote of heparin. So it will bind chemically to heparin and stop its action. So these are chemical action. The third can be action on the enzymes. So there are so many enzymes present in the body. The drugs may inhibit those enzymes. So by inhibiting those enzymes, the action may be stopped. And lastly, the drugs may work on receptors in the body. Okay? So these are the general mechanisms by which the drugs can work. Okay? So we will discuss these two in detail. In this video, we will cover about enzyme inhibitors, and in next video, we will discuss about receptors. Okay. So moving to enzyme inhibitors. The first question is, when a drug work on an enzyme, mostly the drugs are enzyme inhibitors. The drugs are not enzyme stimulators. Reason? Because the enzymes are already working at maximal capacity in the body. It is not easy to further increase their capacity, but it is easy to inhibit them. So mostly the drugs are enzyme inhibitors. Okay? Now enzyme inhibitors, broadly dividing, they may be of two types: competitive enzyme inhibitors and non-competitive enzyme inhibitors. Okay? So the basic thing to understand is, suppose this is an enzyme and this is a substrate. So the substrate binds to the enzyme and then action occurs, or we can say products are produced. Whatever action has been there, products are produced. Okay? Now there are two type of enzyme inhibitors. One is competitive. So as the name tells, there will be competition between substrate and the drug. So we have given a drug whose chemical structure is similar to substrate. Chemical structure is same. So because chemical structure is same, there is competition. So now both substrate and drug are trying to bind to same place. And what is the place where the substrate bind? This active site. So both of them try to bind to active site. If the substrate bind, it will produce the products. But if the substrate do not bind, drug binds, so that enzyme is inhibited. That enzyme cannot work. So that is the competitive enzyme inhibition. So important thing is, whichever is more, that can bind. So what we can do? If we increase the concentration of substrate, if we increase the substrate too much, then more chances that the substrate will bind. Drug will not be able to bind. That means the enzyme can work again. So that means we can overcome the inhibition by increasing the concentration of substrate. Clear? This property is known as surmountability. Or we can say competitive inhibition is surmountable. Surmountable means when we increase the concentration of substrate, we can overcome the inhibition. Okay, so if we revise, in case of competitive inhibition, there are three S. First is same structure. The drug has same structure as substrate. Second is same binding site. Same binding site, that means active site. And third is surmountability. Competitive inhibition we can overcome by increasing the substrate concentration. On the other hand, in non-competitive inhibition, the structure of the drug is different from substrate. The substrate is this, whereas drug structure is totally different. When the drug structure is different, it cannot bind to active site. So the drug bind to a different site, which is known as allosteric site. In a non-competitive inhibition, drug bind to allosteric site, different site. But it is not binding to active site. So how it will stop the enzyme? Now by binding to allosteric site, it changed the shape of the active site. When the shape of the active site is changed, now the substrate cannot bind. When the substrate cannot bind, enzyme is inhibited. So in simple example, you can assume that a non-competitive inhibitor will make the enzyme defective. So when the enzyme has become defective, even if we increase the concentration of substrate, it cannot work. So that means we cannot overcome this inhibition. Whatever enzyme has been inhibited non-competitively, we cannot stimulate that again. So it is unsurmountable. Okay? So in non-competitive inhibition, all three are opposite. That means it has a different structure. It has different binding site, which is allosteric site, and it is unsurmountable. Okay? So that is the basic thing you need to know. Now the last important thing is, in the enzymes there are two important things, which is known as Km and second is known as Vmax. Km is Michaelis-Menten constant, and in simple language, what is Km? It is the substrate concentration which is required to produce the half maximal velocity. Okay? If you try to understand this, the meaning is how many substrates are required so that half enzymes can work. Okay? Whereas Vmax is the maximum reaction velocity. So you need to remember what happened to these two factors in competitive and non-competitive inhibition. Competitive and non-competitive inhibition. So it is very easy to remember. You can remember that Km, it look like kilometer. Okay? So when there is competition, you need to run more kilometers. So in competitive inhibition, Km increases. Whereas in non-competitive, there is no effect. In case of non-competitive, you can remember there is no effect on the Vmax, but in non-competitive, so in competitive there is no effect on Vmax, whereas in non-competitive Vmax decreases. Clear? So in competitive inhibition, remember only one will change. So when there is competition, you need to run more kilometers. So competitive inhibition increase Km, whereas non-competitive inhibitor will decrease Vmax. The other parameter will remain same. You need to remember just this much. Okay. So in the exam, the question is asked on a graph known as Lineweaver-Burke plot, which is also known as double reciprocal plot. So basically they will give you a graph, and from that graph they will ask you to identify whether it is a competitive inhibitor or non-competitive inhibitor. First we will see the basic thing. So it is a graph between two things. It's a graph between two things, double reciprocal. Remember in enzymes we are talking about two things. One, substrate, and second, velocity. Clear? So it is a graph between one by substrate and one by reaction velocity. Okay? So double reciprocal means reciprocal of substrate as well as reciprocal of velocity. Okay? So we'll try to understand the basic thing, how to identify. So if you see on the x-axis we have one by substrate, and substrate concentration which is required to generate half of the maximum velocity is Km. So basically x-axis will tell you Km. Okay? Whereas the y-axis has 1 by V. So 1 by V means it will be telling about reaction velocity. That is the basic thing. Suppose this is a line. This is a line. Suppose graph A. This is without any inhibitor. Without any inhibitor. So baseline is there. Okay. But after giving enzyme inhibitor B or X or Y, so the graph changes. Now the graph is coming like this. So they will want you to identify if black is the line, suppose B is the line after enzyme inhibitor, which type of inhibitor it is. So it is very easy to remember. You need to see that which point is common. So if you see that the point on the y-axis is common here, that means Vmax is same. Y-axis is on velocity. So Vmax is same. Vmax is same. But point on x-axis is different. So that means Km is not same. Km is different. Okay. So in which inhibition only Km changes, Vmax do not change? Yes, that is competitive inhibitor. So this type of graph is for competitive inhibitor. Similarly, if they change second thing, like if they give a graph like Vmax changes but Km do not change, like the graph is like this. Graph is like this. If the graph is like this, the Km is same, but Vmax is different. Vmax is different. So when the Vmax is different, Km is same, this type of graph will be non-competitive inhibitor. So very easy to remember. So just see that which point is common. If Km is common, it will be non-competitive inhibitor. If Vmax is common, it will be competitive inhibitor. It's as simple as that. Okay. So that is important about the enzyme inhibitors. So quickly we will revise what we have discussed in this video. That is a very small video here. So you need to remember first of all what is pharmacodynamics. It is effect of drug on the body. So it include mechanism of action as well as actions of a drug. Then we have basic 4 type of mechanism: physical, chemical, bioenzymes and bioreceptors. And most importantly, you need to remember 2 type of enzyme inhibitors: competitive and non-competitive. And remember, in competitive Km increases, in non-competitive Vmax decreases, the other remains same. And lastly, on the line Beaver Worke plot, or we can say double reciprocal plot, how to identify whether it is competitive or non-competitive, you need to remember that. Okay, so quickly we can discuss the question like identify the enzyme inhibition from the given graph. So if you see no inhibitor is this, then this is inhibitor. Yeah? So we need to see which is common. We see the common point is Vmax. Vmax is common. If Vmax is common, Km is not common, that means it is competitive inhibition. Km increases in competitive inhibition, so it is competitive inhibition. Okay. Another similar question, true about non-competitive inhibition. We know when there is non-competitive inhibition, Vmax decreases, Km remains same. So answer will be Km remains same, Vmax decreases. So this is the answer, first answer. Okay. So it is very easy. So my message is think big, trust yourself and make it happen. It will obviously happen. So whenever you think big, you can make it happen. Okay. Thank you very much.